All right, so now what we're going to talk about is we're going to be looking at what happens if we get away from the parent function. What if we take a times x raised to the n power and we start messing with these values? Because remember, we can express any polynomial function as f of x equals a times x minus h raised to the n power plus k. So we're going to be talking what happens when we start messing with the values of a, x, and k. Remember, n is just changing the shape. We talked about that in the last video. The odd powers either gave us a straight line or gave us that fun-looking s thing, and then my even powers gave us a parabola-looking shape. So what happens when we change a? What happens when we change the value in front? Well, remember, if the absolute value of a is greater than 0, so what we're going to find is my graph is stretched vertically, making it more narrow. And when I say more narrow, I am comparing it to the parent function a times x to the n, where a is 1. I'm just comparing it to x raised to the n power. Well, if the absolute value of a is between 0 and 1, so I'm giving you some kind of fraction or decimal that's smaller than a whole number, this is going to be a shrink. So it's going to be, the graph is shrunk vertically. This is, we either stretch them or we shrink them. And if it's a fraction, it gets shrinked and shrunk. And if it's a whole number, we're going to stretch it out. So if we shrink it, we are going to make it wider. And again, that is compared to my parent function. Well, what if we do some other stuff? What if we actually take the value of a and we make it negative? What that's going to do is it's going to reflect my graph across the x-axis. Instead of opening up, it will open down. And we can see that if we look at Desmos right here. So here's my parent function. And if we make a negative, instead of instead of increasing, this entire graph is decreasing because we have now reflected it over the x-axis. All right. So if we have a plus k, if we add a k, remember k, the value outside the parentheses, because we're still looking at our function. If k is greater than 0, we are going to shift up k units. And if k is, oops, that says greater than, it should say less than 0, we will shift down k units when it's smaller than 0. If we have an h, and if we have a value inside, remember this says always go, the negative is part of the formula. So if h is positive, that's going to represent a negative h inside the parentheses. So we are going to go to the right 8 units. And if it's a positive inside, that means h was negative, and we will go left h units. And then we graph this, of course, and that's going to be a combination of all of those, like we said. And so we can even, if we want to, and we do want to, because, I mean, this is awesome, why don't we take a look at some of those? So if we've got 2 times x raised to the third, and we can do our k translations by adding 4, or so adding 4 moved it up 4. We can come down here and we can actually subtract 4. And it's the same graph, it just slid it up or down. Kind of cool. If we go in and we add a parentheses, a negative, that comes from our formula, a negative value. Let's get rid of all of this. And we will talk about what we have done. So watch what happens to the purple graph. We're going to have an x, and let's do a plus. There we go. Maybe I should have had these, boom, boom, like that. So you can see a minus 2 goes to the right twice because the minus comes from the formula. That's really a positive 2. And since there's already a minus and now it's a plus, that was 2 to the left. There you go. That is, and we can do them in concert with with any changes that we want. So very cool. So if we graph these, well, being able to read it is obviously really, really, really nice. But you know what? There's nothing that says we can't make a t-chart. And that's what I'm actually going to do. But what I'm looking at when I'm seeing this is what I've noticed is A equals -1. That means we are going to reflect over the x-axis. We're going to reflect over our x-axis. We can see the value outside is a +3, so we're going to shift up 3 units. And my shape is an odd power, so normally my odd powers look like this. Well, if we reflect it over the x-axis, that's my parent function. This is what the parent graph should look like. Well, what's going to end up happening, and we're going to see this when we graph it, is we're going to flip it. So instead of going, starting down and going up, we're going to start up and go down. And we're also going to take this whole graph and we're going to move it up 3. And we can see that if we make a t-chart. So let's plug in some x values. We're going to create our x values and then we're going to plug them in to our expression. Now, keep in mind, I know that we went up 3 on the y-axis. So in the middle, we're going to want the point 0.03, and then we can go smaller and we can go bigger and then find all these points. So -2 raised to the 5th power, that's going to be -32, +32, +35. Plug in a -1, raise it to the 5th power, -1, +1, +3, 4. Plug in a +1, 1, -1, +3 is 2. And then plug in a +2, that's going to give me 32. Make it -32. -32 plus 3 is -29. Now, obviously, these last two, the first and last point, we can't graph, but everything else we can. -1, 4, 0, 3, 1, excuse me, 1, 2. And when you look at this, you're like, hey, that's a line. Please remember, this right here in green is what we should be graphing, where it's going to get ridiculous. Boom, boom, boom. And right there is my point of inflection. Right there. Boom. Easy, right? Not so bad. Well, let's graph this one. So what I notice is this is an even power. So my parent function, since it's an even power, will look like that. Well, what are we doing to this? Well, A equals 1/2. Since A is 1/2, that is going to be a shrink. So what happens is when I'm shrinking it, I'm pushing it down, which is actually going to make this U a wider parabola. We are going to shift it down 2 units, and H equals -3, because one of these negatives, there should be a negative in here. If it's a positive, that means the 3 is negative. That means we are going to go left 3. So it should look like this, but it's going to look wider than normal. It's going to go down 2 units and to the left 3. Oh, you know what I didn't? On that last one, let's talk about when it's increasing and decreasing. Totally forgot that part. I just got so excited about the graphing. We'll go back. We'll go back. So if we graph this, there's x. Here's f of x. Because I'm just going to plug it right into there. My middle point needs to be my translations. We're not at 0, 0. From 0, 0, we went down 2 and left 3. So there is my middle point. My middle point is -3, -2. We want to go some values smaller, and we're going to do some values bigger so we can graph it. So when we plug in -5, I am going to get out a 6. Plug in -4, I'm going to get out -1.5. I already know what happens when I plug in a -3. Plug in a -2, I get out a -1.5 because it's symmetrical about the y-axis. Plug in a -1, and I get out a 6. So when we look at these, -5, 6, that's going to be a little bit above there. -4, -1.5. -3, 2. -2, -1.5. -1, +6. And here is my graph. You can see it makes that nice parabola. That's a little wider than it should normally be. So where is this increasing? We are increasing there over those x values. So we are increasing over those x values, and we're going to be decreasing or going down on those x values. So we are increasing the x values. What x values are we increasing from? Well, the vertex is at -3, and then it can go on forever. And then decreasing starts at -infinity, because that's way to the left, and it ends at -3. It is neither increasing nor decreasing at -3, because remember, increasing, which x values have the graph going up? Decreasing, where is it, as we're reading it, where is it going down? Let's look back at this one. Well, remember, all odd powers are normally increasing, but because we have a -a, we're never increasing, because this graph is always going down. And if it's what x values make it go down, every x value. As we go from -infinity to +infinity, my y values just get smaller and smaller and smaller and smaller. So sorry I skipped that and I had to go back, but there it is. If you got any questions, please come in with those questions ready to ask. Glad to help each and every one of you out. And we will see you when we see you.